about again. Okay, so instantaneous rate of change, basically you just take a derivative and plug in that single value. So you take a derivative, plug in the t equal to 5. Now average rate of change is going to be f of b minus f of a over b minus a. That means you plug in 3 and you plug in 1 and divide it by 3 minus 1. So that is going to be your average rate of change. Now again, I like to talk about in terms of motions because in motion it will make a lot more sense. So what happened is, with motion is will be instantaneous velocity versus average velocity. Okay, so they usually means some ideas. So I don't like to talk about instantaneous rate of change because it's really hard to think about those things. But in terms of distance, people can justify that a lot easier. So we have this things happens here. We have a ball is throwing upward at 256 feet building with initial velocity of 96 feet per second. Now, this one, it doesn't really, the calculus question doesn't ask this way. They just ask in terms of motion of some particles moving at a certain things. But I usually start with a particle that is actually makes sense, which is you can throw a ball upwards. Because when you're throwing the ball upwards, then it's going to fall back down. So what happened is, do you guys know like certain things? So for example, do you guys know what's the gravitational constant? Negative what? 9.8. Okay, we're going to use 9.8. So in terms of physics, right? In terms of physics, you're going to have gravitational force is going to be 9.8 meter per second square, and you have to pay attention. You understand the units because units matters. So the gravity is going to be negative 9.8 meter per second. Now, far as calculus goes, I don't know why they still use British system, but it's actually turned out to be nice because that British system was come out is easy to factor, and you will see from this question it will be easy to factor. So the gravitation in terms of feet per second is going to be negative 32 feet per second square. So in calculus we always use negative 32 feet, and that's when back in the day Newton is using they're using like a British system, I believe. And do you guys know the gravitational force in the moon?
1/6 of that.
Yeah, 1/6 of that. Good job. Okay, so it is 1/6 of that. So every time you jump, you're gonna be jump a lot higher, and you cannot run as fast because you'll be bouncing. So that's just the way it is. So physics is gonna be negative 9.8 meter per second, and gravitation force for feet per second square, then it's gonna be negative 32 feet per second square. Okay, so that's a basic understanding. Now, basic kinematic equation in terms of calculus is going to be S of t is equal to half of gt squared plus v0t plus s0. And we're going to talk about why that is half and why that's g and t squared. So in terms of physics, it's going to be negative 4.9 t squared plus v0t plus s0, since we're not doing physics right now. So I don't want to confuse between physics and calculus. In physics, it's going to be negative 4.9. But in calculus, it's going to be s of t is equal to negative 16t squared plus v0t plus s0. And v0 represents initial velocity, and S0 represents initial positions. And S of t represents the position at a given time. Okay, position at a given time. So we're going to talk about the whole idea about everything. Now, also, let's talk about velocity. So after we finish talk about position, the next thing we're going to talk about velocity. How do we get from position to velocity? Take a derivative, right? So if I take the rate of change, then that becomes v of t. But in this case, this v of t is actually instantaneous. How to spell the rest of them? E? Oh, A-N-T. A-N-E-O-U-S. Such a hard word to spell. So instantaneous velocity here. And what if you take a derivative again? So that's going to be v prime of t, and that's equal to acceleration. And you see why that's negative 32 now, because if I take a 2 derivative of negative 16t squared, what am I going to get? Negative 32t for the first derivative, and you take it again, it's going to be negative 32 feet per second. That means acceleration is a gravitational constant, in this case, in terms of gravitation force. Are we okay? Am I confusing? No? Okay. Now, some people, though, the major misunderstanding is this. Major misunderstanding is average velocity. Okay, so average velocity. So what we're going to do is we're going to talk about those. S of t means positions, right? And v of t is velocity. And a of t is going to acceleration. So basically, every time you go down, you take a derivative, right? Derivative. But you go up, you do what? Integration. So antiderivative, right? Integrations. So if you go up, you can take an integration. But the only part that you're going to have small difference is every time you integrate something, you're going to have something else, right? You're going to have plus c involved. So that c is going to involve, that is going to be matter, but we haven't talked about integral yet because we have some students haven't get to that exposure yet. So we're not going to talk about integration yet. We just talk about derivative. Every time I take a derivative, I go from position to velocity, velocity to acceleration. So if I take a derivative, it's going to be like that. Now, what is average velocity? What do you think the average velocity equation is? It's a v of b minus b of a over b minus a, or s of b minus s of a over b minus a.
Say that again?
Yeah, can you?
Or just write it out.
Is it changing of velocity over changing time, or changing position over changing time? Average velocity.
Changing position over changing time.
Changing what?
Position.
Are you sure?
Changing velocity. Changing velocity.
What did the
second?
Nisha's like, damn it, Americans are so stupid. No, I'm just kidding. No, I'm sorry, not to offend you, but it's a very major misconception, because a lot of people think about average velocity is changing of velocity over changing time, but it's not true. It's actually changing position over changing time. Okay, so yes, and I don't blame you for saying that, because a lot of people think that way, even including myself when I was in high school. And I was like, oh yeah, average velocity, easy. I'll just take a derivative. I'll plug in I'll take a velocity. I'll plug in 2 different time over the time change. And I was like, oh shit, I screwed up on the test. And so it is happening to everybody, not just only you. But yes, it's a changing positions. So changing of s over changing of t. So it's equal to s of b minus s of a over b minus a. And guess what? A lot of people are still going to make that mistake on the test. It's a changing of position. So b and a represent 2 different time intervals. And make sure you understand that, because 2 time interval, you plug in. So at time, 30 minutes later, I'm at maybe Claremont, right? If I'm driving to Gainesville, and like 1 hour later, I'm in Ocala, right? So that position relative to here, then you can take that due distance divided by the time given, then you can find out your average velocity. Now, what's the difference between average velocity and instantaneous velocity? Now, that's a very, very different analogy. So I'm going to give you an analogy. For example, I'm driving, that says, it's not going to happen, but if I'm driving 70 miles per hour on Conroy, and I got pulled over, right? And when you get pulled over, what happened? The police is taking the laser gun shoot at that instant, that figure out at that moment how fast you're driving. And that's called instantaneous velocity. But when he pull you over, you cannot tell the police as, look, man, if I drive past the, what's this road? Apocalypse Island, then traffic gonna start, then I'm gonna drive like 15 miles per hour, right? And if I consider that average velocity, I'm gonna be relatively slow once I get to my house, right? And police is not gonna buy that. Police is gonna be like, no, I'm only looking at instantaneous velocity. We're not looking at your average velocity because we don't know what happened later. We know you might crash your car. So we don't know what happened. No, we want to prevent you from crashing your car. So therefore, I want to make sure that I only take account into that minute. Now, average velocity is going to be different. Average velocity is going to be, I here go to your house, how long it take, and how much distance I travel. So for example, from your house to here is, let's say, I drive an hour. I got really bad traffic, but it's only 20 miles. So I'm actually drive 20 miles per hour because 20 miles is a change in distance over change in time. So those are the things that's very, very crucial. Does that make sense? Okay. So, so this becomes a very famous Algebra 2 question. The Algebra 2 question, there was a question like this. They say determine position and velocity function for the balls. Determine the average velocity at the time interval 1 and 3. Find the instantaneous velocity at t equal to 1 and t equal to 3. Find the time required for the ball to reach the ground level, which is usually called a point of impact. Or find the velocity of the ball at the impact. Or finding the maximum height of the ball. So, of all those parts can be answered in Algebra 2. You don't need calculus to answer all those questions. But we're going to make a connection between Algebra 2 and a calculus. So we're going to start doing it today. So let's create, every time you see a word problem, what are you supposed to do? Draw a picture. Good job. And for all the American here, you guys grow up here, when you see word problem, you run away, right? No, I hate word problem just as much as anything. But I love to explain them because they are very, very interesting. A ball is thrown upwards, so I'm draw a picture. So I'm gonna draw a picture. This is a picture of me. And this is me. Throw the ball upward and come back down, right? And the speed I'm drawing is 96 feet per second. I don't know how fast in terms of mile per hour, so somebody can look up for me. I don't know. I think that was a medium throw. That's not even a hard throw. I think I can reach 96 feet per second. Hold on, let me look it up. I'm interested how fast I can throw now. 96 feet per second to mile per hour. MPH, right? Yep. Oh, that's equal to 65 miles per hour. I don't know. I can throw that fast. 65, yeah, I think 65 is reasonable, right? 90 miles is like major league. In high school, like Robert, he said he can throw like 80 miles per hour. I think 65 can reach it. Maybe 60, 65. Yeah, you can throw it just as fast as car. I think that's reasonable. Okay, but just imagine that I'm going to throw in 65 miles per hour. And this actually turned out to be a good number. So we want to determine the position and the velocity function. So how do we determine that? So if I just plug in that, what is the equation I'm going to plug in? I'm plug in is half of gt squared plus v0t plus s0. So this g is going to be negative 32, so it'll be negative 16t squared plus what? What's the keyword here? 96, right? So it'll be 96t plus S0. What's S0? 256 feet. So it'd be plus 256 feet. And that's it. And you're done with the position functions. How do I do the velocity functions? Take a derivative of this functions, right? So if I take a derivative of this function, it's going to be what? Negative 32t plus 96. Okay, velocity function. That's easy. Okay, so that's A. Finding B. Can you find the average velocity? Again, is it changing position over changing time or changing velocity over changing time if you're trying to find the average velocity? The misconception is the average velocity, but it's not true. It's changing positions. So what are you supposed to do here?
Plug the 1 and 2 into the
Position.
Into position. So don't make that mistake before, because before it's okay. Now I have to teach you, so you cannot make this mistake anymore. Please, on AP exam, please understand the average velocity is S of V, S of 2 minus S of 1 over 2 minus 1. I have no idea what 2 is. Can somebody help me plug in if I have 2? Somebody do that part, please. G of 2. I can do G of 1. I'll pick the easy one to do.
It's 384.
384?
Yeah.
Okay, minus what? G of 1?
Where did you get it?
Wait, I think it's 284. Oh, no, it's times 2. Oh, 296.
What is S of 1? Huh?
336.
Wait, what is S of 1 though? 336? Okay. Are you sure about it? So what would be the difference between that? 4? Is 84?
48.
48?
Because it'd be negative 16 plus 96 plus 256. Negative 16 plus 96 is. Oh, never mind. I'm taking off.
Okay, what is the unit here?
feet per second.
Yeah, because you got changing position, means the top part is going to be feet. And the bottom is going to be what? Second, right? And some people do like this, feet, s to the negative 1. That's also working. Make sure that's understandable. So that is going to be 48 feet per second. Okay, so how do I find instantaneous velocity? Plug in the derivative, good. So plug in the 3. So it'll be negative 32t plus 96. So v of 33 is equal to negative 32 times 3 plus 96 is equal to 0. That's weird. At 3 seconds, my velocity is equal to 0. Do you guys know why?
It's accelerating in the opposite direction.
What?
It's going upwards, but it's accelerating in the opposite direction, so it's stopping and going back down.
Okay, Robert?
That's the maximum height.
That's the maximum height, and this is what you say, right? So one of the very interesting question. I remember I was in training, and there was I forgot what exactly the question. I don't remember. Anyway, I'll come back if I remember. So v of 1 is gonna be what? 64 feet per second, right? Does that make sense? Okay, so that's C. That's let's go answer D. Well, did I skip D? Yeah. Jesus. Let's do E then. What is E? Find the time required the ball to reach the ground. How do I do that? Is it possible for me to do that? Yeah? How do I do that? What's a ball reach the ground? What would my substitute into?
Position equals 0.
Position equal to 0 because the last one that is equal to 0. So S of t is equal to 0. So 0 is equal to, in this case, it's going to be negative 16 t squared plus 96 t plus 256. The best thing is to factor out a negative 16. It turns out it's factorable. So it'll be t squared minus, I think, 6t plus what? Minus what? 16? Yeah. It's going to be 16. So in this case, it's going to be t minus 8 and t plus 2. So t is equal to 8 and t equal to negative 2. Now, negative 2 is called a physical domain restriction because time cannot be negative. So time can only be positive. So t is equal to 8. Right? Physical restriction. This is not a function restriction. The function doesn't have restrictions here, but the time restriction is only that 8. So that's the answer E. How do I answer F? F says, find the velocity of the ball at impact.
Just plug in PSA.
Plug in what time?
Plug in 8 into the velocity equation.
Plug in 8 into the velocity, so there's just be the 8, which is in this case is negative 32, times 8, plus 96. I have no idea what's that. 32 times 8 is 256, maybe? Is that right? Yeah, that's right. Plus 96, and is equal to 160 feet per second. Does that make sense? So now, how do I find the maximum height? I know you know. Nicole?
So you're gonna do the same thing, but with time 3, because we know that's when the velocity is 0.
When velocity is equal to 0. Good. So when velocity is equal to 0, why velocity equal to 0 is the maximum height?
Because it's the derivative of position.
What?
It is a horizontal tangent, and it's that's the derivative of position.
Okay, good. So derivative is equal to 0. So derivative is equal to 0. That means my velocity. Because the velocity eventually, if I throw it upwards, right? The ball has a positive velocity, right? But gravity is pulling that ball downwards. As it go up, pulling down more. Eventually, when you go into the highest moment, is the gravity kind of offset your initial velocity, and then the ball start going downwards. And when it's going downward, guess what? That's when you have maximum height. But pay attention to here, though. This is actually interesting. It can be done with calculus way and algebra 2 way. In this question, is not just assume that we don't know calculus. How would I do this in term algebra 2? In term algebra 2, how do you find the maximums? There's 2 ways to do it. Yes.
You just start plugging in times and see what's the highest.
No, but what if you have all the sort of time? What if my time is not integers? Or like 1.27891, then you want to plug in infinite amount of time until you get to there? No. You probably know. Algebra 2, how do I do it? 2 ways to do it.
To find maximum height, you said velocity equals 0.
Yeah, but that doesn't help me with how do I do it in algebra 2? Yes.
So our initial position will be 256, and we will finding the final position, and velocity will be like the initial velocity is given in the question. So plug in these values and we will find the maximum height.
I have to rethink that. I don't know. I need to think about what you say. Yeah, Jonathan?
Wouldn't you just figure out where the start point would have been if the start point started at 0, and then, like, continue the graph down?
The problem is you start at a certain height. The problem you start at the top of the building,
Yeah.
right? So that's a problem. You cannot take the average of two things. If you start on the floor and you throw up, then you can find out the time to hit on the ground, and then you can take the midpoint of that. That's possible. But you're not starting on the ground. You start at the building. Yes, Connor?
Isn't it just a parabola?
Yeah, it's a parabola. So do you remember something called axis symmetry?
Yeah.
How do you find the axis symmetry? There's two ways to find it. One is called completing the square. Why? It's easy. Okay, what's the second way? It's actually within the quadratic formulas. It's inside the quadratic formula. Not a discriminant.
Oh, it's square root b.
No, that is a discriminant, but it's not a discriminant I'm looking for. It's the axis symmetry is negative b over 2a. Do you guys remember quadratic formula is equal to negative b over 2a plus minus b squared minus 4ac? The negative b over 2a tells me where the axis symmetry is. And then, so you can figure out what happens. So you can take the velocity equation. So let's just say we're gonna use that g to find out the time to reach the time to reach your maximum height, right? So I can plug in that. Says t is equal to negative b over 2a, which is negative 96 over 2a, right? Negative 2 times 16. Does that make sense? So that's equal to 3 seconds. Negative b over 2a. Do you see that? That's also a way to do it. And then we can plug in s of 3. And I have no idea what is s of 3. I'm not plugging the ugly number, but you can. 3 squared plus 96 it's negative 16 times 3 squared plus 96 times 3 plus 256. What was the final? Somebody use a calculator to figure it out. I don't want to figure it out. My head hurts when I deal with that number. 400, thank you. So it's 400 feet. So you can actually use that, or you can take a derivative, set it equal to 0, right? Now imagine that if you have take a derivative, how do I get negative b over 2a? So just imagine that if you have a quadratic formula, right? ax squared plus bx plus c, right? How do I get negative b over 2a? You take a derivative. This, just imagine that's position. If I take a derivative to this, what am I going to get? 2ax plus b is equal to 0, right? Solve for x, negative b over 2a. Same thing. That's where the negative b over 2a come from. It's not from nowhere. Well, actually, we know that algebra 2 is negative b over 2a is the axis symmetry, but we don't know that actually calculus could be done in the same way. So those are the things that you have to understand. That you have to understand how do you determine position, velocity, determine the average velocity of the intervals, instantaneous velocity, time, reach the ground level, find the velocity of the ball, find the maximum height of the ball. Anybody who didn't take a physics in this room does not take physics. Okay, so is this confusing if you did not take physics? I don't know. I'm assuming that you did not take physics. I'm assuming that calculus did not go through this part. So I'm assuming about this. So far as internal motion, it's going to be the same. Now, can you tell me what's the difference between speed and velocity? Gabby?
Velocity has magnitude and direction, and speed just
Speed just at magnitude. So, yes, good job. The absolute, so put it on your notes. On the absolute value of velocity, right, is equal to speed. Because speed doesn't care about which direction you go to, but velocity does. Velocity care about you going north or south, or going east or west. Okay, care about the vector, right? So you have to understand that's a lot of things that you have to think about. So those are the things that informing connections. How much time I have? 10 minutes. Okay, so we're gonna go through so we finished the motion part. Now we're gonna give you some homework about this type of stuff, but we didn't go through the integral part yet. But average velocity have a second definition. Do you guys know that in terms of integral? If I give you a velocity, how do I find the average velocity? This is somewhere we're gonna talk about down the road. If I give you a velocity equation, how do I find the average velocity? Yes.
Do you take the integral and then divide that by the interval?
Yes. Think about it. If I integrate a v of t between a and b and 1 over b minus a. So what happens when you take an integral? It's going to be s of b minus s of a, right? So those of you guys take it last year, you guys should know s of b minus s of a. Because you take integral, it becomes s over b minus a. So the second way to talk about something is integration between a and b of v of t dt over 1 over b minus a. So sometimes AP exam, they give you a velocity equation, ask you to find average velocity. Guess what people plug in? Velocity. But you're not supposed to plug in velocity. You're supposed to take integral and take the difference of the time difference. So that's what AP exam always want to check you, and those are the things you have to be very, very clearly think of that. Average velocity is not changing, is a changing position over changing time. That's just one thing you have to know. So in order to do that, you have to take integral velocity to get to a position and then divide it by the time interval. Are we okay so far? Giselle, am I doing okay? You sure? If you have a question, please ask. Okay, so we're going to talk about all the SAT related issues. So we're going to have to take care in that 10 minutes. So I'm going to go through like a fast breakdown. So pay attention. All the relationship that you're going to find in related rate. All the relationships in related rate. And this is just, a lot of you guys, this is already know. So I'm just going to talk about it because, let's just say if I have a square, right? What is the area? Area of a square is what? Side square. How about perimeter?
4 side.
4 side. Good. How about circle?
Pi r square.
A equal to pi r square. And circumference? 2 pi r. Okay, good so far. Let's go to a trapezoid. And this is useful trapezoid rule. So those of you guys remember trapezoid rule from last year. So the area is equal to 1/2 base 1 plus base 2 times the height. Do you remember that? Okay, so let's talk about three-dimensional shape, cube. What is the volume of a cube? Side cube, good. What would be the surface area of a cube?
Area times
6, like a dice. There's 6 sides, so it'll be 6 sides square. Sphere. You guys need to know that for SAT as well. Sphere. What's volume of sphere?
4 over 3 pi r cubed.
4 over 3 pi r cubed. Good. And what will be the surface area?
4 pi r squared.
Do you know why is that? Do you know the derivative of volume is equal to surface area? If I take a derivative of 4 pi r cubed, take it down to 3, 3 cancel out, 4 pi r squared. But only work with circle though. Don't work with the cube. Okay, so that's the relationship of derivative, right? Cone. What is the cone? What's the cone relationship? Do you guys know what's the volume of the cone? Let's go with cylinder first. Hold on, I don't like cone. Let's go with cylinder. Cylinder? What is cylinder?
Pi r squared
Pi r squared times
divided by height.
height. And what will be the surface area? That was kind of tricky.
Pi r squared.
Plus something. 2 pi r h. Plus, plus the circumference times the height?
Yep, exactly. So it's a two circle, right? Plus one sheet of metals, right? Just imagine you have a cylinder cans, right? So circle is a pi r squared. So it'll be 2 pi r squared. Does that make sense? For that sheet, the sheet on the top is the circumference of a circle. So it's what? 2 pi r h. So 2 pi r h. So that's equal to surface area. Okay, cylinder. What else? Cone. What is the relationship of cone? What's the volume of cone? 1/3 pi r cube. No, pi r square h. Because it's 1/3, so cone is 1/3 of a cylinder. You think about a cone. If I have a cone like right here, right? You think about one cone is within, and this is roughly 1/3. Okay, so that's a way kind of visualize for me. It helped me a lot. Any questions so far? Okay. For as other relationship, it could be a similar triangle. Now, similar triangle can be within the cone, so you have to pay attention. Similar triangle can be inside the cone. So, because it's going to be inverted, it's going to go straight down. So, it's A, B, C, D. What's the relationship? Well, A over B is equal to C over D. Does that make sense? But that could be occur in a cone too. So if you have a cone like this, so there was a cone problem last year that you did. There was a similar triangle here happen over there. Okay. So similar triangle is a big one. The next big one with a ladder problem usually is a Pythagorean identity. A squared plus B squared is equal to C squared. Now, with those type of question, pay attention to constant. So, pay attention to constant. There's a lot of times something doesn't change. So, pay attention to constant. What do you mean? A ladder is a constant. The ladder is not increase the length, right? The ladder still stay the same length. So, the ladder does not change. So, when you take a derivative of the ladder, it's going to go to 0. Because derivative of a ladder is the length of a ladder is like 10 feet. Derivative of the constant is going to go to 0. It's going to help you a lot. So pay attention to the constant. That means the things that doesn't change. The thing that don't change. Don't change. Now, whenever you hear tomorrow is going to be the rate of angles moving. So for example, I'm watching a rocket shoot on the moon, and the camera is moving at a certain speed, and how fast the angle is changing, that usually has to do with SOHCAHTOA. SOHCAHTOA. So when it's deal with angle changing, it's going to be SOHCAHTOA only. So, and the trick is to figure out what is the constant has to be on the bottom. So it's opposite over hypotenuse. So that's, you make sure constant on the bottom. Constant on the bottom, because that will be easier to take a derivative. And this will be the hardest case, the constants on the bottom. Okay, sine theta, cosine theta is equal to adjacent over hypotenuse, and tangent theta is equal to opposite over adjacent. So those three situations you can use, but make sure constant on the bottom, because when constant on the bottom, it's really easy to take derivative. If constant's on the top, then you have to take extra step to take a derivative, and makes the problem more messier, make it harder to do. Usually the problem will occur when ladder sliding down. So let's put the questions up, and let's talk about ladder situation. How much time I have? 1 minute? 2 minutes?
2 minutes.
Okay. Now, this is a fundamental question, and some of you guys should already know. If I have a ladder is sliding down this way, right? And not just a ladder sliding like 1 feet per second. Now, is this going down at 1 feet per second?
No. It's just moving to the right.
Are you sure?
Yeah.
If this moving right, is that moving down 1 feet per second?
Not the same rate, probably not.
Well, the question is kind of tricky, right? It's ever 1 feet per second? You feel like 45 would be? Yes. So if you have a isosceles right at that moment, it's probably going to be exactly the same. But when you are on the top, it's going to be a little bit different, right? And then when you're on the bottom, it's probably going to be a little bit different if I'm pointing 1 feet per square. So usually the first time I teach students that they have a struggle with this. So those are the things that people don't understand. If it's at 45 degrees, then it's probably going to go down at 1 feet per second. But if this is a further apart, just like this from this case, if I'm pointing 1 feet here, this is probably moving 1.5 feet per second. It's moving way faster because of the things going to gravity pull on the ground. When you're doing this, you only move 1 inch, then it's probably going to move down a lot more in terms of relationships. So those of you guys never take Calc 1, so you have to know those relationships are various.